In example 1, here we are again solving more quadratic equations. So this one's x plus 2 squared minus 1 is equal to 0. And if you want to use our previous methods to solve this, you would have to square out the x plus 2, perhaps use the quadratic formula, or maybe try to factor this expression. All these ways would be okay. But there is yet another way to solve this type of equation. How we're going to do that is, since the x plus 2 is all squared, I want to solve for this thing by adding 1 to the other side of my equation, just to see what that looks like. I have x plus 2 squared is equal to 1. The interesting thing is, since I have this whole expression squared, I can take the square root of both sides to get rid of the squared, leaving me with x plus 2 on the left, provided that I put plus or minus the square root of 1 on the right. And the square root of 1 is just 1. So this is plus or minus 1. So this is a really fast way to solve a quadratic equation if it's written in this particular form, where you have something that is squared. We call this a perfect square. To solve for x, I'll just subtract 2 from both sides, and my answers are negative 2 plus 1, and also negative 2 minus 1, which simplifies to negative 1 and to negative 3. So if you have something of the form x plus a number squared, or if you have something that is x minus a number squared, we call this a perfect square. It makes solving a quadratic simple because you can simply just take the square root of that whole thing, canceling the squared. So it worked out really well in this equation, and you can check to see that negative 1 and negative 3 are solutions. But let's see how we can apply this method to maybe a more complicated example. All right, so in example 2, I want to solve this quadratic equation, and I could try to factor it. I could maybe use the quadratic formula, but I want to use this new approach of, if there was a perfect square in this equation, it would be extremely easy to solve this expression. But it's not a perfect square. We have x squared, and then we have this 4x, and I don't want that. I would like to have x plus, something squared instead. So what I'm going to do is show you a trick to create a perfect square, making this a very simple equation to solve. And it goes like this. You take the number that's in front of the x, which in this case is a 4. You take half of this number, which is 2, and then you square that result, which is 4. What I'm going to do is take my original equation, and I'm going to put a plus 4 into my equation. But at the same time, I'm also going to subtract 4. And at this step, I just want you to make sure that this equation is actually equivalent to the one that I start with. And it is, because the positive 4 minus 4 is technically 0, which would make it equal to the equation that we started with. But by placing this plus 4 after these first 3 terms, I have created a perfect square. And that perfect square is x plus 2. Think about it. If you square out this 2, you get 4. If you square this x, you get x squared. But you get 2 middle terms. You get a 2x and a second 2x, which adds to give you 4x. So this trick that I used up here, it takes half of this number, which is 2, and it goes right here, because if you double it, it gives you this 4. I then square that number because I have to square this thing if it is a perfect square to get this 4 back. The only other thing to do is combine this negative 4 and negative 5, which is equal to negative 9. And here I have an equation which is equivalent to the one I started with, but it is written in a form that is very easy to solve for x. What I'm going to do is add 9 to both sides. I'm going to take the square root of both sides, which gives me x plus 2 is equal to, well, technically plus or minus the square root of 9, which is 3. And then by subtracting 2 from both sides of my equation, I have my two solutions. X is equal to negative 2 plus 3, which is 1, and negative 2 minus 3, which is negative 5. These two values make the original equation true. And we're using an entirely new idea to actually figure this out. What we're doing is we're adding a number into the equation to create a perfect square. And once your equation is written in this brand new form, it's very easy to solve without any type of special factoring. So let's try this idea of creating a perfect square on one final example where I would like to add in a number after this minus 10x. I'm going to add it in to create a perfect square, and then I'm going to immediately subtract it so I've balanced my equation. But the idea is, what number do you actually add in? What I'm going to do is take the negative 10, and I'm going to divide it by 2, which gives me negative 5. I then square this negative 5, which gives me positive 25, and I've arrived at the number that I'm going to add into my equation. So I have x squared minus 10x, and I'm going to put plus 25, but I'm also going to subtract 25 to make sure the equation I have is equal to the one that I start with. If you combine the 25 and the negative 25, it would just give you 0, taking you back to the original equation. However, these three terms should now be a perfect square. It should be something of the form x plus or minus a number squared. The negative 25 and the 1 combine to a negative 24, and that's going to be equal to 0. The only thing left in this problem is determining what is the perfect square. We've already used the 25. The other number that we're going to use is this negative 5. In fact, I'm going to place it right here. I just want to check to see if x minus 5 squared is equivalent to x squared minus 10x plus 25. If you square negative 5, you get 25. If you square x, you do get x squared. And you get a negative 5x. You get a second negative 5x, which takes you back to this negative 10. So this example is illustrating how this idea works. I'm taking half of this number, because if I double it, it would take me back to this value. Furthermore, it's the square of this number that would give me this positive 25. So it's a tough idea, but you have to kind of like see it all the way through and kind of work your way backwards to see how it all lines up. But at this point, I just look at this value, I take half of it, I square it, and these two numbers have to show up within my work. To now finally solve this equation, it's a very simple thing to do. I will add 24 to both sides. I can then take the square root of both sides, provided that I put plus or minus the square root of 24 on the other side. To solve for x, I'll add 5 to both sides. And here's an example where I have the square root of 24, but that's not going to simplify nicely. I mean, it would be fine, I suppose, to leave your answers as 5 plus the square root of 24 and 5 minus the square root of 24. But as we discussed in class, if you look at 24, perhaps it can be reduced a little bit so there's a perfect square in here. So this is a little extra for this problem, but 24 is the same thing as 4 times 6. And the square root of 4 is 2, but I can't reduce the square root of 6 anymore. You could write your answer as, well, 5 plus 2 root 6, and also 5 minus 2 root 6, but I mean, really, once you get to this point, I'm actually fine with that, where you took your equation, you created a perfect square, and then you use that to solve for x.